Good afternoon, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musings at the Science and Technology Channel.
Yeah, and we're talking about a topic that we've been talking more and more about, and that's AI. And in this case, it has to do with space. So we're pretty interested in this.
Yeah, NASA is developing a powerful new AI-ready space computer chip that could dramatically change how future spacecraft operate in deep space. And this sucker is as big as a Triscuit cracker. You know, the box of Triscuits? That's how small it is. I said big, but it's small.
Yeah.
Created through a commercial partnership, the advanced processor is designed to give spacecraft the ability to process information far more quickly and even make certain decisions independently during missions far from Earth, like we see in the movies. Would you like to know more?
The agency's high-performance spaceflight computing project is focused on increasing the computing capabilities of spacecraft used for exploration missions. Current spacecraft rely on older processors because they are reliable and durable enough to survive the harsh conditions of space. However, those chips lack the performance needed for the next generation of missions. So it sounds like they found the new generation.
Yeah. NASA says more advanced processors are essential for developing autonomous spacecraft, speeding up scientific discoveries through faster onboard data analysis, and supporting astronauts during future missions to the moon and Mars. And
Quote,
to infinity and beyond.
To infinity and beyond, right? Buzz Lightyear. Good character. Okay, quote here. Building on the legacy of previous space processors, this new multi-core system is fault tolerant, flexible, and extremely high performing. This is according to Eugene Schwanbeck, program element manager and NASA's game-changing development program at the agency's Langley Research Center in Hampton, Virginia. Quote again, NASA's commitment to advancing spaceflight computing is a triumph of technical achievement and collaboration, unquote.
At the heart of the project is a radiation-hardened processor built to deliver up to 100 times more computing power than current spaceflight computers. I thought it was 500 times, while surviving the severe conditions found in space. Engineers at NASA's Jet Propulsion Laboratory in Southern California have been conducting extensive tests to simulate those environments.
Quote again, we are putting these new chips through the ringer by carrying out radiation, thermal, and shock tests while also evaluating their performance through a rigorous functional test campaign. And that's according to Jim Butler, High Performance Space Computing Project Manager at JPL. Okay.
To qualify for use in space, the processor must withstand intense radiation. Yes, we know that. Violent shocks, in case it gets bombarded, and dramatic temperature swings that can damage sensitive electronics. High energy particles from the sun and deep space can also create errors capable of forcing spacecraft into safe mode, temporarily shutting down non-essential systems until engineers can resolve the problem.
NASA is also testing how the chip handles the difficult conditions associated with landing on other worlds. Quote, to simulate real-world performance, we're using high-fidelity landing scenarios from real NASA missions that would typically require power-intensive hardware to process huge volumes of landing data or sensor data. That's according to Butler. Going on with the quote, this is an exciting time for us to be working on hardware that will enable NASA's next giant leaps, unquote.
Testing at JPL began in February and will continue for several more months. Early results have been encouraging. NASA says the processor is functioning as expected and appears capable of operating at roughly 500 times the performance of the radiation-hardened processors currently used in spacecraft. At the time of testing, the team marked the occasion by sending an email with the subject line, "Hello, Universe," a tribute to the famous introductory messages used during the early days of computing.
The processor is being developed through a partnership between JPL and Microchip Technology Incorporated, a company based in Chandler, Arizona. Early visions of the chip have already been shared with partners in the defense and commercial aerospace industries.
So just so you know, I graduated from Arizona State, which is in that area, Chandler,
Yeah, Chandler's
Gilbert,
just a kind of a
Tempe.
outskirts of Phoenix.
Yeah, and that area is uh, Intel has fabs for making their chips there, and there's another one I can't remember the name. So that's an area where they've got startups for chip, manufacturing, that kind of stuff. So doesn't surprise me that it's in Chandler. It's pretty cool.
Yeah, and 20 years ago, Chandler was a bunch of fields,
Yeah.
agricultural.
Yeah, now we got 3 temples in that area when we only had one. It's crazy.
Yep, it's like the new Utah.
Yeah. NASA says the technology could allow autonomous spacecraft to use artificial intelligence to react in real time to unexpected situations where communication delays make human input impossible. The processor could also help future deep space missions rapidly analyze, store, and transmit massive amounts of scientific data back to Earth. In addition, the chip may eventually support crewed missions to the Moon and Mars.
The processor is known as a system on a chip, or SoC, meaning it combines the essential components of a computer into a single compact device small enough to fit in the palm of your hand. It contains central processing units, computational offloads, advanced networking systems, memory, and input-output interfaces.
SoCs are commonly used in smartphones and tablets because they're compact and energy efficient. However, the versions being tested by JPL are built to survive for years in deep space, potentially operating millions or even billions of miles away from the nearest repair technician under conditions far beyond anything consumer electronics would experience.
Yeah, now we're talking Voyager, right?
Yeah.
This is cool stuff. Once the technology is certified for spaceflight, NASA plans to incorporate the processor into many types of missions, including Earth orbiters, planetary rovers, crewed habitats, and deep space spacecraft. Microchip also plans to adapt the technology for industries on Earth, including aviation and automotive manufacturing.
The project is managed by the Space Technology Mission Directorate's Game Changing Development (GCD) program at NASA Langley. The GCD program and JPL, which is managed by Caltech in Pasadena, California, guided the technology from early mission requirements and industry studies through development and delivery. NASA JPL selected Microchip as a partner in 2022, and the company funded its own research and development work on the processor.
There you have it.
I like it.
This is like quantum processing, right?
Maybe that's the next one.
We haven't talked about quantum in a while, so yeah.
Get us to infinity and beyond.
Yep. In lightning speed.
Yes.
All right.
Buzz Lightyear speed.
Yeah, very cool.
All right, folks. Thanks for joining us. We'll talk to you tomorrow.
Take care. We'll see you tomorrow morning.